Chapter 1. Integers. Integers. In whole numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, we can subtract a smaller number from a larger number, but it is not possible to subtract a larger number from a smaller number. 7 minus 3 is equal to 4. 8 minus 5 is equal to 3. So a new type of numbers was introduced denoted by -1, -2, -3, -4, -5, -6, such that 1 plus -1 is equal to 0, 2 plus -2 is equal to 0, 3 plus -3 is equal to 0, and so on. Thus we get numbers as -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. These numbers are called integers. The numbers 1, 2, 3, 4 are called positive integers. The numbers -1, -2, -3, -4 are called negative integers. The number 0 is simply an integer, neither positive nor negative. The integers can be represented on the number line as given below. -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. The arrows on both sides of the number line indicate that the number line can be extended infinitely in both directions. Look at the number line carefully and observe every number on the number line is greater than every number on its left. Example: 3 greater than 2, as 3 is to the right of 2. 0 greater than -1, as 0 is to the right of -1. -2 greater than -3, as -2 is to the right of -3. If a and b are two integers and a greater than b, then -a less than -b. Examples: 3 greater than 1, this implies -3 less than -1. 7 greater than 5, this implies -7 less than -5. Absolute value. The numerical value of an integer, regardless of its sign, is called its absolute value. The absolute value of an integer is always positive or 0. We denote it by x, integer. For example, -5 is equal to 5, 5 integer is equal to 5. Thus, integer x is equal to x if x is positive or 0, minus x if x is negative. Example: simplify integer 7 plus integer -7. Solution: absolute value of integer 7 plus absolute value of integer -7 is equal to 7 plus -7 is equal to 7 plus 7, which is equal to 14. Absolute value -3 plus absolute value of integer -2. Solution: addition of integers. Rule 1. To add two integers of like signs, we add their values, regardless of their signs, and put the comma sign with the sum. Example: add +15 and +8. Solution: +15 plus +8 is equal to +15 plus 8, which is equal to +23. Hence, +15 plus +8 is equal to 23. Add -8 and -5. -8 plus -5 is equal to -8 plus 5, which is equal to -13. Hence, -8 plus -5 is equal to -13. Rule 2. To add a positive and a negative integer, we find the difference between their numerical values regardless of their signs and put the sign of the integer with the greater value to it. Example: add 15 and -7. Solution: positive 15 plus negative 7 is equal to plus 15 minus 7, which is equal to positive 8. Hence, positive 15 plus negative 7 is equal to 8. Negative 13 and 8. Negative 13 plus positive 8 is equal to negative 13 minus 8, which is equal to negative 5. Hence, negative 13 plus positive 8 is equal to negative 5. Subtraction of integers. Rule: to subtract one integer from the other integer, convert the integer to be subtracted to its negative and then add them. Example: subtract negative 8 from negative 15. Solution: negative 15 minus negative 8 is equal to negative 15 plus 8. Negative of minus 8 is 8, which is equal to minus 15 minus 8, which is equal to negative 7. 13 from negative 9. Negative 9 minus 13 is equal to negative 9 plus negative 13. Negative of 13 is negative 13, which is equal to minus 9 plus 13, which is equal to negative 22. Properties of addition of integers. Since all of whole numbers are integers, therefore all properties of operations on whole numbers remain useful. We sum up the properties as follows. Closure property. If a and b are integers, then a plus b is also an integer. Example: negative 8 plus 5 is equal to minus 8 minus 5, which is equal to negative 3, which is an integer. Negative 4 plus negative 3 is equal to minus 4 plus 3, which is equal to negative 7, which is an integer. Negative 9 plus 13 is equal to 13 minus 9, which is equal to 4, which is an integer. Therefore, the integers are closed under addition. Commutative property. If a and b are integers, then a plus b is equal to b plus a. Example: 6 plus negative 11 is equal to negative 5 and negative 11 plus 6 is equal to negative 5. Hence, 6 plus negative 11 is equal to negative 11 plus 6. Negative 9 plus negative 5 is equal to minus 9 plus 5, which is equal to negative 14, and negative 5 plus negative 9 is equal to minus 5 plus 9, which is equal to negative 14. Hence, negative 9 plus negative 5 is equal to negative 5 plus negative 9. Therefore, the sums of the integers remains the same in whichever order we add the Associative property. If a, b and c are integers, then a plus b plus c is equal to a plus b plus c. Example: negative 6 plus 7 plus negative 9 is equal to 1 plus negative 9, which is equal to negative 8. And negative 6 plus 7 plus negative 9 is equal to negative 6 plus negative 2, which is equal to minus 6 plus 2, which is equal to negative 8. Hence, negative 6 plus 7 plus negative 9 is equal to negative 6 plus 7 plus negative 9. Therefore, in addition of integers, order does not matter. Additive identity. If a is any integer, then a plus 0 is equal to 0 plus a is equal to a. Examples: 3 plus 0 is equal to 0 plus 3 is equal to 3. Negative 7 plus 0 is equal to 0 plus negative 7, which is equal to negative 7. Hence, 0 is called the additive identity. Additive inverse. If a is any integer, then there exists an integer negative a such that a plus negative a is equal to 0, which is equal to negative a plus a. Negative a is called the additive inverse of a. Example, 7 plus negative 7 is equal to 0, which is equal to negative 7 plus 7. Negative 7 is additive inverse of 7, or 7 is additive inverse of negative 7. Properties of subtraction of integers. Closure property. If a and b are two integers, then a minus b is also an integer. Examples, 11 minus 5 is equal to 6. Negative 13 minus 2 is equal to minus 13 plus 2, which is equal to negative 15. Negative 15 minus negative 8 is equal to negative 15 plus 8, which is equal to negative 7. Therefore, the integers are closed under subtraction. Commutative property. If a and b are integers, then a minus b not equal to b minus a. Examples, 3 minus 5 is equal to negative 2. 5 minus 3 is equal to 2. Hence, 3 minus 5 not equal to 5 minus 3. Negative 4 minus negative 7 is equal to negative 4 plus 7, which is equal to 3. Negative 7 minus negative 4 is equal to negative 7 plus 4, which is equal to negative 3. Hence, negative 4 minus negative 7 not equal to negative 7 minus negative 4. Therefore, commutative property of subtraction does not hold true in integers. Associative property.